Hey guys, Mr. Middleton here. Today we're looking at graphing quadratics notes. At the end of this lesson, you should be able to find the axis of symmetry and vertex from a quadratic function, and you should be able to graph a quadratic. Okay, so from yesterday's notes, we talked about finding the axis of symmetry and the vertex. That is the at least the first step of graphing a quadratic. So let's make sure we're good on that. Identify A, B, and C. Should be pretty simple at this point. A is 1 in this case, B is 6, C is 11. From there, we have to use our axis of symmetry. Remember that formula was x equals opposite b over 2a. And so in this case, that'll be negative 6 over 2 times 1, or negative 6 over 2, which simplifies to negative 3. So our axis of symmetry is x equals negative 3. Remember, our axis of symmetry is a vertical line all the time, every time. Our vertex, we can find it by just plugging our x value into our function. So y equals negative 3 squared plus 6 times negative 3 plus 11. Remember, as you're using your calculator to square a negative, to put it in parentheses, otherwise your calculator will spit out a negative number. We know that it should not be negative. Okay, 6 times negative 3 is negative 18 plus 11. So we end up with our y value here being 2. So negative 3, 2. So axis of symmetry, vertex, solved. Now, from there, that was yesterday's stuff. From there, we're going to take the next step and actually finish the graph. So what we do is we put the axis of symmetry and the vertex on the graph. Our vertex is at negative 3, 2, right here. And our axis of symmetry is x equals negative 3. That is a vertical line that goes through that point. Right there, okay. Okay, so we're good. Axis of symmetry, or the vertex is on the axis of symmetry. Life makes sense still. Now what we're going to do is we're going to create a table of values with the vertex in the middle of the table. So that's negative 3, 2, middle of the table. And we're going to create or choose the x values around our center. So I'm going to choose negative 4, negative 5, negative 2, negative 1. Okay, these are all values that are around negative 3. There's no reason for us not to choose them. And so this is what we choose. Instead of just always blindly choosing negative 2, negative 1, 0, 1, 2, we found the center and chose numbers around it. From there, we plug it into our function, and then we can see what we should get. So our function being, make sure I get that on the screen. There we go, I see it. All right. So I'm going to say y equals negative 5 squared plus 6 times negative 5 plus 11. That's 25 minus 30 plus 11. And so that ends up giving us 6. So when x is negative 5, y is 6. We do the same thing here with y being negative 4. So we have negative 4 squared plus 6 times negative 4 plus 11. That's 16 minus 24 plus 11. That's 3. Okay, do the same thing over here. Y equals negative 2. Or sorry, x equals negative 2. So plug in negative 2 squared plus 6 times negative 2 plus 11. So that's 4 minus 12 plus 11, that's 3. And then we do the same thing with negative 1. Y equals negative 1 squared plus 6 times negative 1 plus 11. So that's 1 minus 6 plus 11, and that gives us 6. Okay, so there we found our values for our table. We can plug it in. Negative 5, 3, 4, 5, 6, 2, 3, 4, 5, 6. Negative 4, 3. negative 2, 3, negative 1, 6. And so we have our U-shaped curve going through there, aka a parabola. All right, so what do you notice about the y values? The y value one step above the vertex is 3, or is the same, I guess is what I wanted to say, is the same as the y value one step below the vertex. Because this is, one step above is 3, one step below is 3. Okay, they're the same. Same goes for the y values 2 steps above and below the vertex. This is because of the symmetry in a parabola. Okay, so it says plot your points and draw your parabola. We've already done that. Okay, and so you see there is a symmetry. We'll actually use that to cut our work in a little bit of half. Okay, because if we know that there should be symmetry here, then if we graph one side of the line, then we can use our symmetry to copy it over to the other side of the line. And we'll see that in these next couple examples. Okay, it says graph each quadratic. Be sure to label your axis of symmetry and vertex. So here, just space. There's just space and opportunity here, and not necessarily walking us through like our previous example did. So we should have that process down. Okay, we first find the axis of symmetry. Okay, our axis of symmetry, x equals opposite b. In this case, that's negative 8 over 2 times a. A in this case is negative 1. So negative 8 over negative 2 simplifies to give us 4. Our axis of symmetry is 4. X equals 4, sorry. So 1, 2, 3, 4. Our axis of symmetry is this vertical line. We know that our graph should be split in half at this line. Okay. From there, we have to find our vertex. Okay, we find our vertex just by plugging this into the function. Y equals negative 4 squared plus 8 times 4 minus 9. Notice that our negative is outside of our parentheses because it's not a part of our x. It's already there. Okay, so 4 squared is 16. The negative of that is negative 16. 8 times 4 is 32 minus 9. So we get y equals 7. So our vertex then is what we're trying to find is at 4, 7. 1, 2, 3, 4, 5, 6, 7. Right at the top here. That's our vertex. Okay, from there we make our table. And those are the 3 steps. To graphing a quadratic. So now let's just complete this table. X, Y. In the middle, 4, 7. And then we'll choose numbers around here. So I'm just going to say 3 and 2, 5 and 6. And because of our symmetry, we know that we don't have to plug in all 4 of these numbers. If I plug these 2 numbers in correctly, it should mirror what I'm going to get for these 2 numbers. Okay, so I'm going to make sure I do that. I'm going to plug 2 into my function. So negative 2 squared plus 8 times 2 minus 9. That gives me negative 4 plus 16 minus 9. So that gives me 3. So when when x is 2, y is 3. We're going to do the same thing with 3. Negative 3 squared plus 8 times 3 minus 9. Gives me negative 9 plus 24 minus 9. So that gives me 6. Okay, so my points then, when x is 2, y is 3, 1, 2, 1, 2, 3. When x is 3, 1, 2, 3, 1, 2, 3, 4, 5, 6. Okay, and because this axis of symmetry splits my graph in half, I can just copy it over. I say, hey, there's a point 1 to the left of the line. That must mean there's a point 1 to the right here. There's a point here 2 to the left. There should be a point 1, 2 to the right here. And so our parabola opens down like this, which makes sense to us. Remember, we talked about this at the last lesson, that our a value is negative, our parabola should open down. That should be a maximum. So that stuff pans out should make us feel like, okay, we did this right. Okay. Next problem, let's try it. So we're finding our axis of symmetry 1. That's opposite b, negative 4 over 2a. So negative 4 over 1, which is just negative 4. So our axis of symmetry is negative 4. X equals negative 4. 1, 2, 3, 4 here. Okay, not really a dot though, so I'm just gonna make sure I know that that's just a line. X equals negative 4 going up and down here. Okay, so from there then, I need to find my vertex, and I do that just by plugging negative 4 into my function. Y equals 1/2 times 4 squared plus 4 times 4 plus 3. Okay, that's 16 times 1/2 is 8 plus 16. Oh, sorry, negative 4. All right. Negative 4, negative 4, plus 3. Okay, so that's 16 times 1/2 is 8 minus 16 plus 3. And so when I get that, that gives me negative 5. One, two, three, four, 5. Okay, got that done. And so my vertex is at negative 4, negative 5. From there, make my table. X, Y. And the center of that table will be negative 4, negative 5. Now, as we look at this problem, before we were just choosing, numbers that are around here, and that's what we want to do. But we also want to be smart about it. Notice that our square value here is going to get multiplied by 1/2. We never really like graphing decimals or fractions. And so to avoid that, I'm going to make sure that I choose x values that don't turn out to be decimals or fractions when I multiply by 1/2. Okay, and that means I'm going to choose even numbers. So I'm going to choose negative 6 and negative 8 here, and negative 2 and negative 0 here. Okay, so I keep my even spacing so I have symmetry, but I also avoid having to plot fractional answers. Okay, and so here I'm going to use these two numbers because I know they mirror the top two numbers into my function. So I have y equals 1/2 times negative 2 squared plus 4 times negative 2 plus 3. And that gives me 4 times 1/2, 2 minus 8 plus 3. And so then I get that to be y equals negative 3. When x is negative 2, y is negative 3. I plug 0 in, that should be a lot easier. Y equals 1/2 times 0 squared plus 4 times 0 plus 3. And that just is 3. Okay. Oops, I said 3 and I wrote 0. 3. Okay, so at negative 2, negative 3, 1, 2, 3, it's 1 point. And then at 0, 1, 2, 3, that point. Okay. On the other side, copy it over, should be 2 over 1, 2, 1, 2. All right, and then here, 1, 2, 3, 4, 1, 2, 3, 4. I'll add it there. Should be a spot there. All right, and there is my parabola. Okay, it opens up because A value is positive. So we should feel good about ourselves that it follows that. And it's symmetrical, so we should feel good. Okay, and so there we go. There's graphing quadratics. Okay, we add it to finding the axis of symmetry and the vertex, making our table, choosing our values around there, and we're able to complete that process today. All right, see you.